Hey, here we are, back to the CPM book. Today's homework's a little bit strange because we're not doing all the problems on the review and preview like we normally do. We're actually going to skip two of them that us teachers don't like for a couple different reasons. One is because we're kind of teaching that one subject in science more, and another is just there's some weird problems. We don't like the numbers that much. So we do like these though. So we're going to go back and do 2-43, and then we're going to do all these problems except for these two, 248, 249. So we're doing 243, 246, 247, 250. That should go in your heading. Okay, that'll remind you the problems you need to do. I will almost certainly get an email from someone saying they don't understand how to do 248 or 249, right? And I'll ask the kids, please read those directions and watch my video. All right, so here we are. What are the easiest 3 points you can ever get? Yes, they are. Okay. Pete Townsend. Who is that? Who is that? Okay, what is today's date? Oh my goodness, you guys gonna participate in the trunk or treat, right? And don't forget to put your teacher name and your period. And again, that's an abbreviation you can use. And I think we should include the problem numbers, okay? You can do 2.2.3 and then do numbers 243, 246, 8, who do we appreciate? 247 and 250. Sorry for the dumb jokes. That's kind of where I am. Okay, so let's look at 2-43. It says find the area of each figure in at least two different ways. And note that in each figure, all of the angles are right angles. Okay, explain how you get your answers. That's an important thing to note. They're all right angles because what do we know how to get the area of? Well, the only thing we've really covered this year is how to get the area of rectangles. Okay, and again, remember, a square is a special kind of rectangle. So when you get the area of a square, it is a rectangle, and you multiply how wide it is times how tall it is, and that's important because we need to turn these into rectangles so we can do that. And remember, right, when you do a problem like this, it's like eating a big old burger or burrito that you like. You don't eat it in one bite. Okay, you cannot do these problems in one step. Okay, slice it up into easy steps and put them together. Okay, make that problem easy by chilling out a little bit, relax, and take your time. Okay, whenever you have a problem like this, I definitely recommend drawing the picture, even if your picture is not perfect. Mine never is. Okay, you want to make it as good as you can. Okay, and draw it. Now, I just recognize by looking at this picture that this is 6 tall, so I'm going to make use of these lines and have every two lines, or every line be one unit, okay? So if that's 6 and this is 5, I'm going to go over not quite as far as I went up, all right? And if that's 2, I'm going to use those lines, right? Now this is 8, so I'm going past the 5, and then another 3 more. I'm estimating about like that, and again going up 2. All right. Now this time I'm going back 3. So if that's 5, I go more than halfway back, right? All right, and then it goes down, and then it goes over. Okay. Now that's not perfect, but that's pretty good if I do say so myself, right? Go ahead and label it. Okay, and if you would like to press pause and go do this and catch up, that's a great idea, right? So this is A, okay, and I don't know if you noticed this. There's no number here. There's no number. Oh, there is a number there, but there's no number here. So we need to figure out using our brains and observation and inference and logic kind of thing. Wait, that's science, Mr. Daniel. So anybody know, we had to use some logic in our brains and what we know to figure out what these two numbers are before we can get the perimeter for sure, but we don't need the perimeter, but also before we can get the area. Okay, so let's do that, and then I'm going to write B here and go ahead and draw this picture. Now this is 13 and 5 and 5, so it's about 10 tall, 13 wide, 10 tall, and it's 5 and 5, so go in the middle and go down. You want to use these lines again? Okay, you might say, but Mr. Daniel, that's wasting paper if I draw my picture that big. Hey, paper's cheap. You want to learn how to do some tough math, okay? Don't be afraid of using an extra sheet of paper. And I could almost guarantee we're still going to get this done in 1 or 2 sheets anyway. 1, 2, 3, 4, 5. And then I'm going over, I don't know how far, but it looks like it's about the same. Okay, don't be fooled. Sometimes pictures are not drawn to scale, which means, you know, you'll have something that looks like it's a bigger line and it's actually shorter. This book has done that a few times, and we don't like those problems. And hopefully we have marked our books to skip or redraw the picture, making it harder than it needs to be by not having the drawing correct is not something we want to do. We want to teach you how to do stuff, make it as easy as possible. Here we go. So we have those, okay? And again, there are missing numbers here, okay? But this is pretty easy to see, right? If this line was drawn across here, then this is a rectangle. And if that's 5, this has got to be what? 5, right? And if that's 5, this space in between here should be 5. And if that's 4 and this is 5, what's left to make 13? Well, that's 9. 13 minus 9 leaves me with 4, which is good because that makes this drawn to scale. It looked like it was the same, it is. And if that's 5, the opposite is going to be 5. Remember, opposite sides of parallelograms and rectangles and squares are the same, right? Okay, so we got those missing numbers. Let's get the missing numbers here. If this entire length is 8 inches, and, this is going to be hard. Let's wait on that one and get this one, okay? So this is 2, and this is 2, and this is 6. So from here all the way up to here is 6, and this part of it is 2. I have 2, 2. What's going to be? I think you guys figure out that's going to be 2 as well. All right, now this hard one. Okay, now we have 8, but this only went out 5. So this went out 3. So what's this distance right here? Well, 5 minus 3, that's going to be 2, right? So that means this down here is going to be 2. And now I can figure out this, right? Because I know this whole distance is 8, right? And if that whole distance is 8, then this part of it's 2. What's left here? 8 minus 2 is 6. Okay, so it helps me to have all those numbers. But now we're looking for area. So I want to make this into the easiest thing to get area. Rectangle. I'm going to break this up. And there are all sorts of ways of breaking this up. Okay? I think you guys can see that I could break this up by making this rectangle here, which is 5 by 2, right? That's a rectangle I can get. I can get this little square, 2 by 2, right? And I can get this long skinny rectangle going this way, 8 by 2. Okay? I can also, if I wanted to, figure out this rectangle is 6 times 2. And then do this one over here, 2 times 3. And this one over here, 6 times 2. Okay? And I put them together. All sorts of different ways. Okay, same idea here. You can do this square that's on top, this rectangle on the bottom, and you need to come up with another way, okay? So that's how you're going to do those. Let's go on to the next problem, 2-46. Oh, another one like that, okay? So I'm going to get another piece of paper on that one, give myself some room. again, paper is cheap. Okay, if I wasn't writing in pen, I'd do the back side of this, but I want to write in pen so you guys can see it a little bit easier when we do it on the dot cam. Okay, so 2-46, I'm going to draw this. This is 10 tall and 10 wide. I'm going to go ahead and make use of my lines again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a square, so go about the same amount off that way. Okay, now I'm going up 5. Okay, over 4, so not quite as much as I went up. Okay, down 2, over 3, so not quite as much there, and then all the way up. Okay, now I know that this is 10 centimeters. They gave me that. This is 3 centimeters. They gave me that. This is 4 centimeters, 2 centimeters, 5 centimeters, and again 10 centimeters. All right, so what do we want to do here? We want to figure out the missing numbers, and we want to break this into some rectangles, right, that we can easily figure out the area, because remember, a rectangle, you're just multiplying the length times the width. Okay, so if this is 3 and this is 4, from here all the way to here is 4 plus 3 is 7, right? And if that's 7 and this entire thing is 10, okay, what is this up here? That's going to be 3, 10 minus 7, right? Now, if this is 10, and this went up 5, but then I went down 2. So this here is 3. And this is 10. So what's this here? It's 10. This is going to be 7. So I can get the perimeter now by adding the 10 plus the 3 plus the 7 plus the 3 plus, right, all the way around. And I can get the area. You can choose, okay? You can choose how you want to break this up. I'm going to go ahead and break this up into 3 rectangles. This one, and this one. Okay? And then I'm going to add those up, put them together. All right, 2-47. Draw and label 2 different rectangles, each with perimeters of 20 units. Do the rectangles have the same area? Explain. So 20 units. Now, rectangles, the perimeter is 20. That means half the perimeter is 10. I'm looking for numbers that add up to 10. You can do 9 and 1, right? If you want, I'm going to say 9 wide and 1 tall, because halfway around would be 10 centimeters. All the way around, we double that, 20, right? So that has a perimeter of 20. And I'm using centimeters. They just said units. Okay, centimeters, easier to abbreviate. Now I want to do another one. Well, you want to go 2 and 8? You want to go 5 and 5? Let's do 5 and 5. Okay, that is going to have, and again, a square is a rectangle. It's a special rectangle. It's a special rhombus. So that has a perimeter of 20 as well. Figure out the area and answer that question. You're going to do that. And you don't have to use 9 and 1. In fact, I challenge you to use 2 different ones. Okay? I sort of showed you a method of figuring out a rectangle with a perimeter of 20. Okay? Try to use 2 different ones if you can. Challenge yourself. Okay? All right, we're skipping these 2. We're down to 2-50 and 2-50. Oh my goodness, this is going to be easy. It just says, consider the units in this list: inches, centimeters, feet, yards, meters, kilometers, or kilometers, and miles. And for each given below, list the units that would be most commonly used to measure the length or distance. Okay, so I'm going the distance from Bellingham, Washington. My daughter almost went to school there. That is way up near the Canadian border, right? It's actually closer to Vancouver, Canada than it is Seattle. and I would have gone broke if she went to school there, not to mention not being able to see her. All the way to Washington, D.C. Oh my goodness. That's across the country. Okay, so hint, hint, I'm going to use the biggest two choices I have there. How about the length of a small stuffed animal? Teddy bear. Okay, C, how far you walk at lunchtime at school. I'm going to write lunchtime walk. For me, I walk home for lunch. And the height of your classroom. How tall is your classroom? Well, here in California, what do we worry about more than any other natural disasters? Earthquakes. Our classrooms are usually fairly short without heavy things up top. Length of your shortest fingernail. I'm just going to write fingernail. Okay. And what are you going to use here? Okay. So we have standard units and metric units, and I want you to give a guess and then come back later. I will make another video giving you all the answers, but I think you can do that yourself. I think you can do this, and I think you've done enough. We got you started enough that you can finish these. All right, good luck. If you do get stuck, come to an afternoon Zoom or ask the teacher in the Zoom for help on that problem, okay? Do it ahead of time so you don't miss any points.